Hi, welcome to Wizard Works. Today I'm going to show how I took an Arduino Nano, a gyroscope, and some servos and made a pan tilt sensor from it. And my thought process behind on it is for a search and rescue robot, what we could do is use the tilt sensor as kind of an FPV head tracking system. And the servos can be used as a camera to be able to have the pilot or a secondary person look around, look for a distressed person, distressed animal, or whatever else they need to look around for. Sometimes with electronics you get little hiccups. This servo that was doing the tilt mechanism was just acting up, wasn't moving very quick and kind of jumpy, and so with that I had to replace it. From the good servo, it was able to move a lot quicker and better. From that, the tilt sensor, the tilting was able to move a lot better. And here's our code. What we have is our assigned variables, we have our servos, and we have our three functions that help with our calibration and our sensitivity of the sensor. First one is calculate the IMU error. What that is we go on down to our third function, this guy right here. We run the code 200 times. Each time it's going to get the error and divide it by 200. From that, we get our error, our initial error. From that, we get our initial readings. We read from the sensor again. We subtract our calibration error from the normal reading to get that. Our drift error, we don't have that yet, so that's still going to be 0. From there, we go up to our get drift. Our drift is where a sensor isn't perfect and it kind of varies over time. It'll start to drift off. What we do with that is we take our known and we get a good idea. We take 200 readings, find the average of it, and then we take it from our known. So we'll take 200 readings. From that, we take our calibrated, so our first reading, subtract it from what our current reading is, and we get that our drift. Same thing as the initial one, we just do it 200 more times, we get our sum, we divide it, and that's our drift amount. From there, we go to our void loop, our main loop. We read from the sensor, like normal. We apply our calibration error, and we apply our drift error to get our normal reading. We get our roll, pitch, and yaw, and then what we do is we use map function, which is basically a computerized way of being able to ratio 100 to negative 100, or whatever other variable you want to what other variable you want. So I want it to be able to servo value, so 0 to 180. So that's what I put on there. I get anywhere between these readings. It converts it between 0 to 180. Same thing with the other servo. Then from there, I just told it to write the servo to that number, and that's it. Here's a view of our serial monitor, starting off the code, and then I'm resetting it. Takes a second to boot up. Then we have our normal gyro error. Then we have our drift error. Then it applies to it. And that's our steady readings from the sensor. Thank you for watching. I hope you have a great day.